In this video, we are going, well, in this series of videos, we're going to talk about fluid mechanics, but in particular density. And we want to talk about density in this particular video. I'm going to focus right there. So what is density? Typically, I do like to, well, I'm just going to write a formula. And we typically refer to density as rho equaling to m over v. So what is rho? So rho is just, it's considered the density. So in this particular case, we're going to call this density, okay, of a material. And then we have mass, or we have m. M is just the mass of that material. And then we have V, where V is just the volume of the material. So if we just draw that over here, right here, let's just say we have this cube, okay? And let's say that the cube has a length here. It has a depth. And it has a height. All right. So then what would be the volume of that cube? Well, we know that volume in that particular case would just be the length times the depth times the height. Okay. And mass is just going to be a result. I mean, I could say mass is going to be, if we put it on a scale, we can figure out what the mass is going to be written in kilograms. So this thing is just going to be in kilograms. And you can get it from a scale. Okay? So now that we know mass and we know the volume, we would be able to calculate the density. And that would just be the mass over L times D times H. Okay, if you so needed to do that particular calculation. Now, what would be the density of a sphere? So let's just go ahead and draw a sphere up here. So a sphere is something that's three-dimensional. Okay. The thing that we would need to know, it can be the same kind of material, but the thing that we would need to know would be the volume. How do you calculate the volume of a sphere? Well, the volume of a sphere is just going to be equal to 4/3 pi r cubed. So if you ever run into something where you have a volume of a sphere, that's how you calculate it. And what about, oh, and so you just put that back in to the density, and you end up with mass over 4/3 pi r cubed, which is just going to end up being 3/4 m over pi r cubed. All right, all I did was take the 4/3 to the top and flip it over. Okay. The next one that I would like to show you guys would be the volume of a cylinder. So let's say that we have another three-dimensional coordinate system. And we have ourselves a cylinder here. Okay. This cylinder has some height associated with it. Okay. and it has a area here. Okay, and so how do we define the density in this particular case? Well, this object is going to have some mass, of course, and then it'll be over volume. But how do we define the volume of this sphere? Well, volume is just going to be the area. It's a product. The area times the height. Okay? But what is the area? The area in this particular case is just the area of a circle. So this is what you see on top here. And this circle is going to have some radius, r. The area here is equal to pi r squared. So that means we can put all of that back into this formula here, and we'll end up with pi r squared times h. That would end up being our volume, and so the density of a cylinder would be the mass of whatever that cylinder is made of times the volume, divided by the volume of that cylinder. So that's pretty much all I'm going to talk to you guys about in this video. The next thing we're going to talk about is pressure in a fluid, or the definition of pressure.